Hello students and welcome to my channel Maths Hub. So in this video series I will talk about multiple integration and today specifically I will be talking about triple integrals. Now what are triple integrals? Triple integrals are when there are three integral signs together inside one integral, and here when we check the order of integration can be either dx, dy, dz, or it is dy dx dz, or it is dz. You can keep any order, right? And whatever order you are keeping, accordingly you have to put in the limits. So for example, if I have the order as dx dy dz, so you can see that the innermost integral is with respect to x, then the outer one is with respect to y, and the outermost is with respect to z, right? Okay. So now how can we keep the limits of the integral? Neither the limits are specified in the question itself or the region is given over which we are integrating it. So by plotting that region, we can determine the limits of x, y, and z. So usually, if the innermost integral depends on z, then the limits of z are set as a function of x and y, right? Once the innermost integral is completed, then the value z gets over from the function and we are left with an integral in x and y, right? So if the second integral depends on y, then usually the limits of y is dependent on x. And once this integral is also done, so we are only left with the variable x, and so we can see that the limits of x is always constant, right? Likewise, you can set up any order and accordingly you can place the limits of the integral, right? So let us see some few questions on how we do these integrals. So the first question says, evaluate triple integral over r x plus y plus z dx dy dz where the region r is x lies from 0 to 1, y lies from 1 to 2, and z lies from 2 to 3. So if you check this region, all the limits of x, y, z are constant. So when the limits are constant, it becomes very easy. You can keep the order in any way. So the way it is given to us in the question, we will take the same order. That is x plus y plus z. And the order that is fixed is dx, dy, and dz. So if the innermost integral is with respect to x, we will check the limits of x. It is from 0 to 1. So we will place the limits as 0 to 1. Then you can see that the next integral is with respect to y and the limits of y are from 1 to 2. So we place the limits of y from 1 to 2. And finally, the limits of z is from 2 to 3. So we will place the limits of z as 2 to 3. So let us perform the inner integral. Now when we perform the inner integral is with respect to x. So you can see that the variables y and z, they are constant. So we can integrate this as 2 to 3 integration 1 to 2. And when I integrate the integrand with respect to x, keeping y and z constant, integration of x is x square by 2, integration of y is xy, and the integration of z is xz, and we place the limits as 0 to 1, integration with respect to y and integration with respect to z. So now let us put the limits in x. So the first two integrals are kept as it is. So now when I place the limits of x as 1 and 2, the first term becomes 1 by 2. The second term becomes simply y and the third term simply becomes z. Now I need to perform this integral with respect to y, keeping now z constant, right? So now when we do this integral with respect to y, keeping z constant, so we keep the first integral same. Now we will keep the variable z constant. So integration of half will be y by 2. Integration of y will be y square by 2. And integration of z will be zy. We place the limits from 1 to 2. And now the integration is with respect to z. So let us place the limits now. So when we place the limits of y as 2 and 1, so 2 minus 1 is 1. So we will get 1 by 2. Y square is becoming 2 square, that is 4 minus 1, that will become 3 by 2. And the last one, we will place the limits of y as 2 and 1, so it is z. And now we will integrate it with respect to z. So now when I integrate it with respect to z, you can see that x is also gone and y is also gone. So it is a single integral now dependent on z. So 3 by 2 plus 1 by 2 will become 2. So I can club them and I can consider this as 2. So integration of 2 will become 2z and integration of z will become z square by 2. We place the limits as 2 to 3. And now when I put the values, this is 2 times 3 minus 2 will become 1. And I'll take out half common. 3 square is 9 minus 2 square is 4. So this is 2 plus 9 minus 5 is 9 minus 4 is 5. So now that becomes 2 into 2 is 4. That is 9 by. So this is your answer for the first one. So I hope it is clear. So you have to do it step by step, very carefully, checking out which integral you are doing and with respect to which variable. So whichever variable you are selecting for the integral, the other variables have to be kept constant. Right? So I hope this question is clear. And now we move on to the second question. Now in the second question, we need to evaluate integration 0 to log 2, integration 0 to x, integration 0 to x plus log y, e to the power x plus y plus z, dz, dy, dx. So now if you check the order here, you can see that now we have to perform the inner integral with respect to z. And after performing this, the next integral will be with respect to y and the outer one will be with respect to x. So let us take one integral at one time. So let me write down this is equal to 0 to log 2. Then we have 0 to x and then we have e to the, okay, let me write down the integral. Or let me do one thing. I'll do the innermost integral first. Whatever answer I get to the innermost integral, then I'll pick up the next one, right? So I'll take e to the power, 0 to x plus log y, e to the power x plus y plus z, and we have the integral with respect to z. So I'll take it one by one. Now, when we do the innermost integral, the integration is with respect to z. So you will be keeping the variables x and y constant. So let us keep it constant. So e to the power x plus y is constant. So what is integration of e to the power z? It is e to the power z. And we will put the limits as 0 to x plus log y. When I put this value, we get the answer as e to the power x plus y. And now when I place the values here, this is e to the power x plus log y minus e to the power 0. So this is how much? This is e to the power x plus y into e to the power x into e to the power log y. So that is y minus 1. Right? So I can break this up. I can write this as y into e to the power x plus y. So this is e to the power 2x into e to the power y, and I can write the second term as e to the power x into e to the power y. Right? So I hope the innermost integral is clear how to solve it. Now let us take the next integral. The next integral is with respect to y. So for that we have 0 to x and the integral is y e to the power 2x e to the power y minus e to the power x into e to the power y, and the integration is with respect to y. Now when I integrate it with respect to y, I have to keep the variable x constant, right? So from the first integral, e to the power 2x is constant. Let us integrate y into e to the power y. Now I have to apply the Eilert rule. So according to the Eilert rule, your algebraic function is the first function and e is the second function, right? So how to integrate it? We will integrate it as first function same, integration of second function minus integral derivative of first function, which is 1, and integration of e to the power y is e to the power y. We will place the limits as 0 to x and we will integrate it with respect to x. Sorry, we will integrate it with respect to y, right? So now this is the first one. Now for the second integral, e to the power x is constant. Integration of e to the power y is e to the power y, and we place the limits as 0 to x. How much is this now? Now here e to the power 2x is common. Now I have to put the limits of y as x. So it is x e to the power x, and when I place 0, it will become 0. Minus. Now what is integration of e to the power y? It is e to the power y. And when I put the limits 0 and x, I will get e to the power x minus e to the power 0. Similarly, the second term will be e to the power x, and when I place the limits, I get e to the power x minus e to the power 0. So that makes it as e to the power 2x, x e to the power x, minus e to the power x, minus into minus is plus, minus e to the power x into e to the power x is e to the power 2x. This is 1, so this will become plus e to the power, right? So let us expand it. This is x e to the power 3x minus e to the power 3x plus e to the power 2x minus e to the power 2x plus e to the power x. So e to the power 2x cancels and these three are the leftover terms, right? Now, finally, we need to integrate 0 to log 2. The terms are x e to the power 3x minus e to the power 3x plus e to the power x with respect to x, right? So what are the integrals now? Again, we will be applying the pilot rule over here, keeping x as the first function and e to the power 3x as the second function. So first function same, integration of e to the power 3x is e to the power 3x by 3, 0 to log 2. Then minus integration 0 to log 2, derivative of x is 1, integration of e to the power 3x is e to the power 3x by 3 dx, minus integration of e to the power 3x will be e to the power 3x by 3, 0 to log 2. And similarly, integration of e to the power x is e to the power x, 0 to, right? So let us plug in the values in this. So finally, this will give us, I can keep 1 by 3 outside. I will have log 2 multiplied by e to the power 3 log 2. So what is e to the power 3 log 2? It is e to the power, this is e to the power log of 2 cube is 8. So it will simply become 8 log 2, right? And when I put in 0, it will become 0, right? The next term is minus, so this term is this much only. Then we have minus 1 by 3 is already there. So when I integrate it, I'll get e to the power 3x by 9, 0 to log 2. Now when I put in the limits here, I will get 1 by 3. This is e to the power again 3 log 2, which is simply 8, right? And when I put 0, I will get 8 minus e to the power 0 is 1, right? This is what I'll get. And in the next term, what am I supposed to get? E to the power log 2 minus e to the power 0. So this is finally 8 by 3 log 2 minus, how much is this? This is e to the power, I can keep 1 by 9 constant. This is e to the power 3 log 2 minus e to the power 0 minus 7 by 3 plus, this is 2 minus 1. Finally, we get 8 by 3 log 2 minus e to the power 3 log 2 is e to the power log 8, which is 8 by 9, minus minus plus 1 by 9 minus 7 by 3 plus 1. So finally this is 8 by 3 log 2. So this finally becomes, when I solve it, it becomes minus 19 by 9, right? You can just check the terms. You have minus 8 by 9 plus 1 by 9 is minus 7 by 9, minus 7 by 3 plus 1. So 9 is the LCM. We will get minus 7, 9, 3 and 21 and plus 9. So 9 minus 7 is plus 2. So it is minus 19 by, right? So these are the calculations and I guess you get the same answer, right? So I hope this is clear how to solve this question, right? When the limits are given. Do it step by step so that you don't commit any mistake, right? Okay. So we will move on to the next exercise, that is evaluate triple integral x square plus y square plus z square dx dy dz, where R denotes the region bounded by x0, y0, z0 and x plus y plus z equal to a. So let us set up the integral limits. So we have triple integral x square plus y square plus z square. We will generally fix up the order as dz, dy and dx. So it's simple. Now when the inner integral is with respect to z, we can clearly see that the lower limits of z is 0. And from the equation of plane, we can set up the limits of z as a minus x minus y. Simply take out the value of z, right? Now once the inner integral is done, the variable z will go and now we will be left in only two variables, that is x and y. So the equation of plane gets reduced to x plus y equal to a. So if you plot this region, this is the plot, and if the integral is y, we can take a vertical strip in this region and we can see that the entry point of the strip is y equal to 0 and the exit point of the strip is a minus x. And the minimum and the maximum values of x is 0 to a, right? So now let us try to perform this integral. We do the first innermost integral. So the innermost integral is 0 to a, same, 0 to a minus x also same. X square integration is x square z. Then we have y square integration is y square z and z square integration is z cube by 3. Limits from 0 to a minus x minus y dy dx. So let us put up the values of the integral limits. 0 to a, 0 to a minus x. So we have x square into a minus x minus y plus y square into a minus x minus y plus a minus x minus y whole cube divided by 3 dy dx. Right? So now let us do this integral. So when I perform this integral, I'll get 0 to a. The first term is ax square. So we will have ax square. We are integrating with y minus next term is x cube. So we will get x cube y. The next term is minus x square. Integration of y will become y square by 2 plus a times y square will become y cube by 3 minus x constant integration of y square will become y cube by 3, then minus integration of y cube will become y4 plus y4. Now for this term, it is a linear term. So the integration is simply a minus x minus y to the power 4 by 12 now. And now there will be a negative sign also. So I'm changing this to minus. right? And we will place the limits as 0 to a minus x integration with respect to. So let us put up the limits now, the upper and the lower limit. So we have a into x square, a minus x minus 0. So this is the term that we will get. Then we have x cube, a minus x minus 0 again. Then we have x squared by 2, and again we put the limits as a minus x whole square minus 0. Then we have a by 3, a minus x whole cube. Then we have minus x by 3, a minus x again whole cube. Then we have minus a minus x to the power 4 by 4 minus. Now when I put y equal to a minus x, the upper limit will become a minus x minus a plus x to the power 4 divided by 12, and the lower limit will become simply a minus x to the power 4 by 12, right? I hope you got this term. And now we will integrate it with respect to x. Now when I integrate it with respect to x, what am I supposed to get, right? Now this term, I need to open it up. So when I open it up, I will get my values as a square. X square integration will become x cubed by 3. When you open it up, the next term, this is a x cube. So x cube integration is x4 by 4, right? The next term, minus ax cube. So this will be ax4 by 4. The next term is x to the power 4. So that is x to the power 5 by minus. Now what about this term? Let us open up this term here and I'll integrate it accordingly. I'm not left with much space. So this is minus x squared by 2 into a minus x whole square. So this is a square plus x square minus 2ax. So when I solve it, I'll get minus a square x square by 2. Then I have minus x to the power 4 by 2. Then plus 2 cancels and I will get ax cubed. Now I need to integrate this term. So the first term will become a square x to the power 3 by 6 minus x to the power 5 by 10, then plus a x to the power 4 by 4, right? Now let us pick up the next term. So this term is a by 3. A minus x whole cube will become a minus x to the power 4 by 4. So that is 12, and there will be a negative sign also, right? Right. Then this term, the next one. So let me check out what is this term now. Now this term is, let me rewrite the terms over here so that it becomes easy for you to check and easy for you to write the integral also, right? So now we have minus x by 3, a minus x whole cube. This is a cube minus x cube minus 3a square x plus 3a x square. So when I open up the brackets, I get minus a cube x by 3 plus x to the power 4 by 3 plus 3 cancels a square x square minus a x cube. Now let us integrate this. So this is minus a cube x square by 6 plus x to the power 5 by 15 plus a square x cube by 3 minus ax4 by, right? Then the next term would be, I can simplify these two terms together. So I have 1 by 12 and I have minus 1 by 4. So 12 is LCM, I'll get 1 minus 3, that is minus 2 by 12, that is minus 1 by 6. So I will have minus 1 by 6, a minus x to the power 5 by 5, so that will become 30, and plus minus will change to a plus sign, right? Okay. And finally, we have the next term to be integrated is this one. So here you can see that a cancels. We will have minus 2x to the power, sorry, yes. So you can see that a gets cancelled, x also gets cancelled. So this term is becoming 0, isn't it? Okay. So now let us try to simplify this term and we will put the limits as 0 to a. When I put the limits as 0 to a, we get a to the power 5 divided by 3 minus a to the power 5 divided by 4 minus a to the power 5 divided by 4 plus a to the power 5 divided by 5 minus a to the power 5 divided by 6 minus a to the power 5 divided by 10 plus a to the power 5 divided by 4. Now when I place the terms here, when I put the upper limit a, it will become 0. And when I put the lower limit, what will happen? I will get a to the power 4, but I will get a plus sign here. So I'll get a to the power 5 by 12 over here. Then next term would be a to the power 5 by 6. Next term a to the power 5 by 15. Next term a to the power 5 by 3. Next term a to the power 5 by 4. And now again when I put the upper limit 8 will become 0, but the lower limit will make it a to the power 5 by 30. So let us see is any term getting cancelled or not. You can see a to the power 5 by 4 is getting cancelled with this term. A to the power, okay, let us search for some other terms if it is getting cancelled. A to the power 5 by 5 is not getting cancelled. 10, okay. So here you can see that we have 2a to the power 5 by 4. So that will become a to the power 5 by 2. And this is a to the power 5 by 3. So a to the power 5 by 6 and a to the power 5 by 3 is getting cancelled. Then what else can we check out for? A to the power 5 by 3 and okay. So this is a to the power 5 by 15 minus a to the power 5 by 30. So that will make it right. So you can see that this term will get cancelled with a to the power 5 by 10 and finally we are left with these terms, and when you simplify these terms we have minus a to the power 5, this is 2a to the power 5 by 4, that is a to the power 5 by 2, then we have a to the power 5 by 5, this is left, and then we are left with a to the power 5 by 12 and we are left with a to the power 5 by 3. So if I check out these terms, I can simplify these two terms also together. So I will get 5a to the power 5 by 12. Okay, so let me take the LCM as 60. So this is minus 30. Then we have 12. Then we have 5 over here. And then we have here 20. So that becomes, so after doing the simplification, you will find that these terms, after simplifying, it will become a to the power 5 by 20, right? So I think you can do these calculations on your own and you can check out these terms, right? Okay. Now you can check your progress. You can do these two questions and see whether your answers are matching. I've given you the answers alongside. So do these questions and do let me know in the comment section if there is any doubt. Right? So thank you for listening to me. And if you haven't subscribed my video, do subscribe my videos to get the latest updated video. do subscribe my channel. And if you like the video, do hit the like button. Have a nice day. And if you believe in yourself, you can definitely do it. Thank you so much.